Oh, I got the software tuning finished. This one. Actually, the final version is motor control version 56 because I changed the loop marker duration. I shortened it a little, but otherwise it's this. And let's see, I'm testing with the power supply, so I'm going to show you the display. Powers up. Let's see. It's difficult angle, but now switching on. And it has this scrolling text, and there's the software version. And 25 FPS gear. So, and A tuning. So I'm going to show this again. And this I will make a tutorial separately. But the idea is, here is the select button. This another button is wired for start and stop. This is the control button. So when powering up, if you hold this down when you actually switch the power on, before you see any text scrolling, then it resets the internal memory of this display software. So it resets the tuning selection, it resets the speed preset, and it resets the memory addresses to the default ones. So this every time you change the speed, for example, then it saves immediately the speed preset. So if you switch the camera off, then the speed preset remains, so you don't always need to select it when switching batteries. But there is dynamic memory address selection system, so after certain amount of saves, the memory address moves to next memory spot, so it doesn't wear out the single memory spot if it would always save to the same location. So resetting the whole system resets that, then it resets the gear type to 24 FPS gear. This is the gear type is. So for most of the CP16Rs, this gear is black, and it is for 24 FPS use, and it is marked on the camera, and the original back panel has the selector with 24 gear type presets, including 24 FPS crystal, and this red gear is typically 25 FPS, and these cameras have the 25 FPS speed dial on the original panel. But this update system is made so because it doesn't make sense to change the gear types, and these gears are impossible to get separately unless you get one custom made. So I'm sure Chinese would love to custom make this completely new. But if you want to use the original ones, you have to take one from the camera. You can get this separately. And coincidentally, everyone wanted to use the 24 FPS cameras. So some cameras which are on sale are with this 25 FPS gear. And if you are using the original electronics, then you are stuck with the 25 FPS crystal because it's the only crystal speed these cameras originally have, either 25 or 24 or 25, and it is changed by changing this gear. The electronics stays the same, the motor stays the same, only this gear changes. So the other gear has one, the 24 FPS gear has one teeth more on here, yes. and this has one less because it's 25. But on the new electronics, it doesn't make sense. It would be completely stupid to change the require you to change this gear, and instead I have made 2 sets of speed presets for each, one set for each gear type, and it's changed in the software, and when starting up you can change it. So when the text scrolled through, you saw the I need to turn this a little too. Okay, now the power switch on. So connecting it again. I'm trying to not circle the power supply. Yeah. So let's switch it on again. Switching on. Now it starts scrolling. Then CP16R display software version, motor control version, and then there might be batch and gear type 24 5 fps. I can tuning. Now it's in standby mode. I will show you how to change the gear type. Switching on. Wait, don't press anything. Now press when you see the first text scrolling, then it goes to wait a little, gear changed. Now you can release. Then it goes here. Gear type changing 24 or 25. When you have selected, or if it was correct already, then just wait. Waiting a tiny bit. Okay, this became a tutorial. I didn't mean to make a tutorial. It became a tutorial. So I can just show you this. So now waiting. This takes a while, and the function of the button changes depending on at which point the now gear set, yes, and now it lost the gear type. Yep, and if you now press the button, it changes the tuning, and you can't select it if it just changes it to other tuning type. So now it changes to B tuning. And after the gear type text scrolls, after that it flashes which tuning it has, either A or B, and then it lost to the standby mode. It just flashes for 1 second, the tuning type. And the difference between tunings is that the B tuning is kind of safe mode. So it has it's very difficult to hear when running the camera or the show, but the A tuning is set so that between 14 fps and 30 fps it tries to maintain to very long term sync too. So it basically counts the frames from the point when it reaches the correct speed, correct running speed. Then it starts to count frames it runs. If it skips 1 frame forward or backward, it tries to correct it long term. So if you shoot a really long take, it should stay in sync. If it's very minutes long, it should stay in sync. If the speed fluctuates up and down, it tries to correct the difference when it can. And the B tuning doesn't have that feature. It's on purpose, because if your camera would behave very differently than my camera, the long-term sync correction system might start the speed, because the speed fluctuates too much on some cameras with some settings, and I wanted to add the kind of safe mode which doesn't have that, a tiny bit risky tuning which has the very long-term sync capability. The B tuning is almost as accurate. It is a tiny bit more stable running speed. So basically running speed at any given time, and then the long-term sync, if it drifts some frame to some direction or not. Those are basically. So if talking about PID controllers, PID, so proportional integral derivative. So proportional is the running speed at any given time, the speed right now, and integral is basically the long-term sync. Derivative is that it tries to basically remember or simulate beforehand how much it needs to correct speed when some change happens. So it measures the change, and then it has some logic to guess how much it needs to correct, so it kind of remembers that. So the B tuning doesn't have, it basically has only the proportional, but because this camera is pretty stable running and it has the flywheel and pretty low friction, it can be almost as accurate as basically it's the A tuning is PI fully and a tiny bit of D. So it's a PI controller and half D controller. So almost bit controller, but I'm developing the software still, but this version is already working, so I'm using this for the first batch, but the November version might be different than this. It will have a tiny bit better stability at low speeds and better derivative function, so it can guess the necessary corrections better than this version. This is running okay, but yes. So I changed, what tuning did I have? Now, talking too much, and now I need to switch it on again because I don't remember anymore. So display software, motor control software versions. If you need to know them, they flash the gear type, then tuning flashes now, B tuning, and standby now. So basically 25 FPS, the film is in the magazine. I have like 20 meters, but it is not threaded. My sync boarding LED is there because I haven't made the cabling yet. And the shutter parking is, yeah. So and when you have installed this and run it the first time, if you hear like very loud clanking or something, it is usually the belt slipping. So the belt is probably too loose. If you hear some weird sounds, it's not the crystal control, it's the belt usually. And if you hear those sounds every now and then you notice the sync drifting, then it's the belt slipping and physical has physically has slipped some frame forward or backward. That's all. Not the crystal control's fault. It can have sync issues sometimes, but theoretically, but if you hear weird sounds, it is probably the belt always. So that was, what did I say, 25. Let's change the tuning. And like I said, this, now wait, we have to wait. Don't press anything yet. Then the gear type. When the gear type starts, now you can press when the gear type starts rolling. And then it says the tuning. Now you can release a tuning. Tuning set. And A. And standby. And now it's in A tuning. And this software version, it's, what did I say, it's 55 and 56 it was, is what is loaded to the first batch of the installation kits. So this has to under 14 FPS and over 30 FPS have the same tuning. Basically it's the B tuning always. It doesn't have the derivative because integral, sorry, little bit tired. So it doesn't have the integral functions or the long term sync measuring and correction. But that is because when running with low voltage batteries like the 20 something volts, so if you use this with original batteries, when running over 30 FPS, it is pretty close to the upper limit of the safe region. So when running the crystal sync, if here is the 0% of the motor power, and here is 100%. So when running 24 FPS, for example, it's running the median motor power is somewhere in the middle. And then when it needs to correct, it adjusts the motor power up and down, and it has good headroom in either direction. But when running over 30 FPS speeds, it often is pretty, with 20 volts batteries, it is often pretty close to the upper limit already. So it has good headroom to correct down, but it doesn't have that good headroom to correct up. So the A tuning is not very well working in that situation, and the B tuning is actually better, usually much smoother running. So, and better speed stability by my tests. So the A tuning only works between 14 and 30 FPS, and I have switched it off on other speeds because the B tuning works better on those. So the A tuning mainly controls how the mid speeds 25. You can see, let's let it park first. Yeah. Look the sync light. Oh, it first it treats the sync. It is a little bit different friction, but it reaches the sync about the same time. Yeah. So there is very little difference you can hear. I don't think you probably don't hear any difference between this and the previous tuning also. Yeah, now you hear it. So there's when it starts to drift a little bit too much, it corrects, and A tuning does it more sharply than the B tuning. So because this has the long term sync accuracy feature, the A tuning has that. So it needs to correct fast if it starts to drift before it drifts too much, because then it would need a huge correction which shows in the image. So when it starts to drift a tiny bit too much, then it corrects back, and it's actually done so that it uses kind of similar speed regulation system than the B tuning when it is very close to correct. And the A tuning basically kicks in when it starts to drift a tiny bit too much. How did I say it? It's like 1/8 of one frame or something like that. 1/7 or 1/8 of one frame. If the difference is more than that, then it corrects, and it corrects it back, and then leaves it back for the B tuning to handle the fine accuracy. So the B tuning handles the very fine stability, and A tuning corrects if it quickly, if it starts to drift, it corrects like this. And if you run this with, so if the A tuning is on, if you run this with B tuning set on the menu, startup menu, then when it starts to drift, it is like a rubber band. It gives some freedom, but it then starts pulling back more and more. So it doesn't make the quick changes like A tuning. It does like this. It depends on the frame rate and anything how, and a tiny bit about the camera how it works, but let's switch this off. So when installing this, you will basically install the main board without the motor. And you can see I have cut with a tiny bit of cutout here. And this is absolutely necessary because you can theoretically fit the mainboard here without cutting this, but then the motor will push the mainboard towards the shutter sensor, basically the blade which is mounted to this axle, which rotates and cuts the light to the shutter sensor. So if you don't cut this, then you will push the mainboard too much to the front direction, and it will hit the rotating axle and create noise and might break something, even if you don't care about the extra noise. So basically you will take the motor off completely, take the motor mod off from here, and then install the main board correctly, then put the motor tiny bit back so you can see where this corner is and mark it down with the marker, and then cut this groove for the circuit board. So it's for the corner of the circuit board. and it is very necessary, don't forget that. But first install the main board without motor, and then try with the motor plate how much you need to cut from here, and then cut it and then install the motor when you have this cut. And after you have installed those two, then you can start to arrange the cabling. This camera doesn't have the final cables yet. I have just the test cables. I will make some cables tomorrow, but so here is one power input. This is usually meant for real panel disconnector if you want to put on battery there, and this secondary no, this is for motor. So this is, yeah, and it of course reads on the circuit board, and there's polarity too. This is the power input A and this is power input B, and they are marked and there is polarity and everything, so use this. So this is usually, you can connect these vice versa, it doesn't matter, but this is usually meant for rear panel 6-pin connector, and this is meant for onboard battery. And you may connect these differently if you want. There is no wire connection police who comes to find you if these are connected differently. So in final version, so I will add one screw here and one screw here to secure the I/O module in place. And it has possibility to add 2 screws, but I recommend one here. And you can use this hole to tie down cables or something. It's much easier to manage the circuit board if it only has one thing. And this is actually a bolt coming through the circuit board, and it is only secured with the nut. So when this is mounted and final and tightened, you will need to secure this with Loctite or super glue. Because if this nut would loosen or drop off, then the other end of the bolt would hit the flywheel. So it is important that this is very well secured. And this is absolutely needed because the board is pretty large and it needs support from the center. So there's, I don't know if it can be seen, but on the camera body casting there's a groove on where this screw mounts. Near that point there is a groove on the casting where the corner of the circuit boards goes, the main circuit board, and then we have this securing the center part of the board. Then we have this screw securing the upper part. Then under the shutter sensor there is the LED, infrared LED board, and that is supporting this point. So that is important too, but I have set the spacing here, so it should be correct. I showed in the previous videos that I have tested it with camera, so it does work. So we have the motor connected here, then we have a power here. And then this goes to the back panel, it goes to the display, and this selector switch. And this start-stop switch is connected to the same cable cabling than this connector. And I have the start switch and engine switch. So engine is here. When the motor is running, then this works as pace button. It has dual use. When stopped, it is engine. When running, it is pace. And push once for starting and second time for stopping. And you can see the shutter parking has delay. Now it's waiting and then parks. And if you push the engine before it starts, then it disables the parking function for that deck. Let's see. Now I push the engine button, now it doesn't park. It disabled it. But with very short pushes of the engine button, you can manually inch. This is because you will want to every now and then check the gate, so you can use the manual engine. Very short pushes. Let's turn the camera a little. So you can use short pushes of the engine button to rotate the mirror open, like this. Here is the shutter parking. And it is very handy to be able to check the gate without opening the side door at all. So now it's after the take it parked, and then very short pushes of the engine button, and now the gate can be checked, and then when ready, couple of short pushes and we can close the shutter. Like this. Yep. So it's pretty reliable. And if the shutter parking for some reason doesn't work, then you can use the engine button to park the shutter, of course. And this engine speed adjustment is fully analog, so it kind of tiny bit depends on the operating voltage. So you will basically adjust this for the batteries you are going to use with the camera. So if you change the, let's see, I have set it like this, set it to be something like between 2 and 4 FPS or something like that. Let's see if we switch this off and it was 21.2. If we change it to something like 23 and switch on. This made this electronics so that it can handle about 26-27 volts easily. The motor doesn't like it, but the electronics can tolerate it just fine. So if you want to run speeds like 48 or 50, you might need 24 volts battery. Haven't tested it for a while, but and the stability is not guaranteed in this firmware version. Let's see so you can see it is faster. Let's see. Yeah, you saw that I can adjust this lower, and it with the 21.2 volts it could have been lower speed and still the parking working perfectly fine. So So it could have been lower, but now it's with the higher voltage battery, the shutter parking is not very reliable, and I may need to manually park the shutter like this. Let's see the shutter. This is very easy to do. I was originally not going to add the shutter parking, but it's of course it's handy, but it's kind of a selling point, really. I could just fine park with this. It totally works, but so if that's why I have the engine button here. So it's really handy and necessary, and if you use different voltage batteries with this, then it might be necessary to use the engine button sometimes to park the shutter, because you don't want to open the camera body all the time just to reach this adjustment. So adjust this with the batteries you most often use, and then if having some different voltage, then park manually if it doesn't work correctly. So here it's usually around 20 milliamps what it takes in standby when running. It's still pretty low because this motor is pretty low power. .420 shutter parking, yeah. It rolled one, basically it tried once and immediately tried second time. So it did work, but it's not reliable if it's not adjusted for the voltage you are using this with. Let's see. So something like this might be pretty common with the 20 volts batteries. And I did try this with 14.8 volt V-locks, but those are not good enough for 24 FPS. So if you are shooting 16 FPS and something like 20 FPS, then it might be fine. I can just show you, but I will change the tuning to B tuning, because let's say the V-locks are something like 16 point something, and full might be like this, and then changing to B tuning. Let's see. $25. I haven't actually tested it. It does work, but let's set higher. It will probably be more unstable than with correct voltage, because there's less headroom for adjustments. Let's 30 FPS. So this is how you change the FPS. You hold down the button until the number starts to change, and you can actually push this to go upwards. It only goes up, and then after 50 it goes back to 4. Let's, what did I say, 30 FPS. And when finding a correct preset, then leave it alone and wait a tiny bit, couple of seconds. I don't remember if it was 5 maybe FPS set. Now it's correct. And one bit of warning, because there is the A tuning and B tuning, of course, but this runs the display control software, the user interface. This is the crystal control processor. There's two different processors, and when the FPS is selected and FPS is set, then this processor communicates with this to send some individual tuning presets. So there is kind of ranges to really low speeds, to medium low speeds, to mid sync out speeds and the high speeds. And it communicates those after the frame rate is set and enabled. So if you start the motor before it has confirmed the speed change, and you have changes from one region to another, for example, from low speeds to high speeds, then, and starting before it has set the speed, then when the camera runs, it is still in low speed tuning. So you always, when changing your speed, always wait the confirmation notice before starting the camera. It is because if getting, for example, the low speed tuning for the sync sound speeds, it is pretty horrible. So you will probably need to stop it and then start again. You don't need to change the speed again, but you will need to stop the camera and wait for the shutter parking and then start again. And then it enables the different settings for the different speed range. So no, I will now. It does run at 30 FPS. Let's set some. That is the sound I was talking about. That is the belt slipping. The belt slips and it creates this sound. So now the sync is on. Sync light is on. So it can barely reach 30 FPS and then not luckily even that. So if you might be able to use vlogs at 24 FPS, but I wouldn't use them for anything higher. For example, 44. So speed selected, then wait until you see the message. Or if speed set and now it communicates the speed range when it starts to show the standby, the frame standby mode, the frame rate again. You can see it can't reach the 44 FPS. It's not horrible running, but I don't know the real speed it runs, but probably something like 36 or something. So let's raise the voltage a little to the same level we always had. But if you don't have tons of different battery voltages, this is working fine. So I made this to be used with the original batteries, and it can work with 24 volt batteries, but you will need to tune it a little. If you have different voltage external battery, which is higher voltage than the onboard batteries you use, then I recommend just adding a down converter. Do I have once, for example, something like this kind of Chinese, really cheap, costs like maybe $4 or something like that. So adjustable down converter, so you can control the voltage and then adjust from the converter the voltage to the same level than you have on the onboard batteries. And because you need to measure it with the multimeter, the voltage from the batteries, and then adjust this and measure the output voltage of this to set it to the same level. Because batteries, when charged, they have higher voltage than the nominal voltage. So you will need to know the actual voltage. Don't just look the text on the battery, it doesn't tell anything. But yeah, in the next video I will put film in this. Basically it doesn't have any difference other than the sound, so it runs the same. I actually measured it with the power values, and it was like, was it taking 5% more of power when running the film actually. It was really low. I was surprised how low the friction was in the moment. But I think it was 5% or 8 or something like that. It wasn't over 10%. So the difference without film and with film is pretty low. If you need to simulate how it would run with film, you can just hold the take-up like this. So this is almost the same than running with film. So it does run 44 FPS with 21.4 volts. So you can test the top speed if the sync LED switches off, then it's fine. And it doesn't make any weird sound, so it changes up and down wildly. This sync warning LED is supposed to be routed to the same position than the original was, and you can wire the same warning to the original tiny LEDs which are on the viewfinder. They can't be seen, but behind the corner of the board there's the viewfinder and the original LEDs, so you can wire them to the sync warning directly. And even another LED might be recommended to only wire one, but you might wire two. There is current limiter resistor anyway. And I do have LED. So let's see. LED light here. I talk about the blooper marker. So there is the blooper marker output which can be wired to something you like. I'm checking the polarity of the LED. So the longer wire is positive, then taking the ground from here. So I have blooper marker and now starting the camera. And this is one firmware version lower than the one in the first match of the port. So the difference is that the marker, when stopping it, gives it immediately. When starting it, I set it, I think it runs 2 feet and then gives the mark or something like that. I have to check it, but it runs certain amount of frames and then gives the mark. And the only difference to the final firmware is that this mark on this earlier version is a bit longer. So the mark is half the duration when using the final firmware, but otherwise it is the same, the timing and everything. So this, you can wire this to a summer or something, or wire a LED and put it somewhere near the shutter so that it focuses the film when starting, and put a summer elsewhere. The current you can take from here is pretty low, so you need to amplify it some way if using those higher powered summers, but you can use LEDs, one single LED with this if needed. You can ask for instructions if you need to amplify the signal. And start stop goes here, and what did I say? Where it goes? The inching and start stop. So we can, let's see, we have from memory the markings are underneath, but ground. Then we have start stop, I think, inching, frame pulse, one pulse for each frame shot, and then the blooper marker, and then the 4.6 volt output, 80 milliamps, like said here. But if using, I have possibility to make really affordable simple footage counters, so those can run at 4.6 volts. So that's the connections from there, and those are then wired to back panel and front panel connector. Let's see, the low speeds are pretty unstable on this firmware version, but we can test them too. They are not great, but you can find some use for them, I think. Over 12 FPS is pretty okay already. This is the 6-pin connector, meant for footage counters and start switches, and so I don't have this wired on this camera yet, but I will include the wiring kit with the final devices. 4 FPS. And with low speeds, don't mind about the sync warning light. These are not very stable, and probably the light stays on or blinks. This is interesting. Do you see that? This one. That's the infrared LED. I don't see it with my eye, but the cell phone camera sees it. That is the infrared LED, that purple tiny dot there. So you can see the shutter parking sensor, the rotating plate which cuts the light. Works there. And we can actually show you the shutter parking. Yes. And if rotating it a little, yeah, this is interesting. I didn't remember that this is air light. Engine. Yeah, interesting. But 4 FPS is usable. It's not very stable, but it does work. 5 and 6 FPS are a tiny bit better. These are crystal sync frame rates, but the sync is not very stable, so I wouldn't shoot sync out scenes with these, but it is stabilized to a point. 6 FPS is better, of course. The flywheel, it makes it easier to run when it is not super slow. So we can check something like 10 FPS, 10. We have 10. And I talked about the tuning issues with these low frame rates. The 10 FPS is not that bad, but you can hear it's a bit unstable. You can use this, of course, but I will get this a bit better when you can see the higher LED there again. Now the sync warning actually works with 10 FPS. These are pretty usable, but I can get this better with more time. I have already used 2 months for tuning this, so this is pretty nightmarish combination. It has really low power motor, belt drives are always nasty. Then it has those gear drive, which is connected to the huge flywheel. This is actually 2-part flywheel. You just don't see the other part behind it. You can see that. That is the fixing point for the axle, which has one of the 2 axles which has the felt disc which acts as a dampening between the 2 flywheels. So this has small axle and there's one on the other side, and those run the other flywheel behind this. So there's 2 large flywheels, very underpowered motor, belt drive, and gear drive in addition. That's why I think this is one of the most difficult cameras to make crystal sync for, and that I don't hate making this, but it's really difficult. So, but this works pretty well at the sync sound speeds, so it's not the end of the world that the low speeds are a bit unstable. 16 FPS is pretty good. 16, let's see. So when I changed from 10, did I show to 12 or 10? But anyway, changed from that to 60, then it changed to next frame rate region of the tuning. So there's 4 different regions and 2 different user changeable tuning presets, the switchable tuning presets. So basically 6 different combinations. This is 16 FPS, pretty good. It's not as good as the 24 and 25, but perfectly usable. It's a bit better with friction added from film, but anyway. Let's compare it to the 24 and then stop the video because it's been an hour already, so 24. And you can there's the markings that for example 23 preset is 23.976. I didn't want to add extra decimals to the display. It would have been too big display for this. But 24 works. So I will first make the kits. I have already measured the correct cable lengths and I will make the cable kits for the final installation kits I will send to the customers, and then after that, when I have time, then I will tie the cabling of my own camera. So I will shoot with this camera especially because I figured out how to use GoPro as a video assist with this by removing the original lens of the GoPro. And this is the original video relay lens of the CP16R. The original one. I don't have the original video camera for it, but I can use GoPro with this and removing the lens from GoPro so that this focuses the image directly to the GoPro sensor without any intermediate lens. So I will make either CNC machined or 3D printed adapter to attach the GoPro to the correct position, and then it does work. Let's see if we can. No, we can't see anything. But anyway. And when thinking about it, you can see the clutch belt. It is easy to get the motor belts. It is not easy to get these clutch belts. I think, was it White Point Digital or something who sold on eBay? This on eBay something like 5 years ago, still 8 years ago, maybe 5 years ago. But they don't sell this anymore. I don't know where to get new ones. This is basically, so there is the flywheel and the main sprocket wheel, which tries to film, is connected to this, and then the shutter and movement is connected to this axle with via gears. So this is basically for mechanical footage counter here. There is the worm drive to drive the footage counter, and then it's for the here is the slipping disc for take up belt drive, but if at some point it becomes impossible to get these belts, then I think this system, the whole belt system and this could be just replaced with the electric motor, or one could run this with the electric motor, or make a small driving system here which has small electric motor and slip disc which drives this. So this could be driven electrically. There is not absolute need to run it with a belt from here if it becomes impossible to get the belts, but this will last for years, and I will probably sold this camera next year, so because I will only need it until I have made all the batches of these boards, and I will probably only make them in November and December this year, and then sell the camera. So I will set up the video tab, of course, because can get much better price from the camera then, and shoot test film, of course with it, and yeah, no Super 16 modifications or anything Ultra 16, because this is much better with the butterfly shutter. This is much better with normal 16, and I will include the zoom lens I have and some spare parts, but it is next year then. So just a thought that if it becomes impossible to get these belts, then we will arrange some kind of electrical way to drive the take-up, or even similar system than for example on Bolex or 16S motors, those where there is small electric motor on the magazine itself, and then it is connected to the camera body with sort of cable. But let's see. I'm now updating the firmware of the sales kits I have prepared, and then make the cables and send everything, and then we'll make more Ampere project work, and we'll resume this in November. The firmware, of course, I will shoot with this now in September, but we'll send installation kits first, and then finish my own camera to shooting condition, because other people want to shoot with these systems too, so don't let them wait for too long. So yes, and this firmware has speed presets between 4 FPS and 50 FPS, and they seem to work okay, and we'll keep those for the first batch and likely the second batch too. So yes, now switching this off and going to do something else for a while, and then finishing the installation kits.